Good afternoon, everyone. So I see people are trickling in. I'm just going to wait a few seconds so everyone joins. But we are very excited today. Dr. Caban-Martinez is going to be presenting to us on the ultraviolet light sunlight exposure assessment among career Florida firefighters. So again, I'll give it a couple more minutes. Numbers are still trickling in, so I'll wait to do the introduction. All right, so it's 12:01. I think the numbers have slowed down, so I will go ahead and get started. Thank you all for joining us for our monthly seminar series. So today we have the privilege of hearing from Dr. Alberto Caban-Martinez, who is our co-deputy director of the Firefighter Cancer Initiative. He also sits as the associate provost for research integrity and regulatory affairs and assessment. He's an associate professor of public health sciences and leads our FCI and our environmental exposure team. So without further ado, Dr. Caban-Martinez will be presenting today on ultraviolet sunlight exposure assessment among career Florida firefighters.
Awesome. All right. Good afternoon, everybody, or good morning, wherever you're joining us from. And thank you, Dr. Sali, for that warm introduction. So I'm excited to kick off our new FCI year 8 with our new firefighter cancer seminar series. So for those of you that may not be aware, we were fortunately renewed again by state appropriation to continue in the 8th year of the Firefighter Cancer Initiative. And this month, July, marks the start of that 8th year. And we're excited to be able to kick off the monthly Firefighter Cancer series with a chat on ultraviolet light and skin cancer. Before I begin, I'd just like to take a moment to acknowledge the research team that helped to put this research work that I'll be presenting to you together. The funding comes to us from the state of Florida appropriation to Dr. Aaron Kobitz, our principal investigator and director of the Firefighter Cancer Initiative. This project today, called FUSE, was organized and collected by the team that you see in front of you. So Allison Zhang, who was our medical student, has since graduated and is now a resident in surgery. Catalina Gonzalez Umana, who is a firefighter EMT paramedic, was a student undergrad and is pursuing her firefighting career. Ms. Paola Louzado-Feliciano, who's with us today on the panel, who helped orchestrate many of the data collection elements here. Dr. Min Liu, who is our biostatistician for this project, and Dr. Schaefer Sally, who is co-investigator for this data collection. So we've organized today's presentation across 5 topics. The first one is we'll talk a little bit about what is ultraviolet light radiation. Then we'll jump over into human skin anatomy and physiology, so we have an appreciation of how ultraviolet light ultimately impacts skin anatomy. Then we'll take a look at skin cancer burden in our Florida firefighters and why we're concerned about this as a type of elevated risk. I'll introduce and present to you the results of the FUSE pilot study, and we'll wrap everything up with some tips on sun protection, as this month is Skin Cancer Awareness Month. So let's begin with the first topic, which is ultraviolet light radiation. So what is ultraviolet light, particularly solar UV? So the term UV is short for ultraviolet radiation. And this type of radiation can be carcinogenic to humans, depending on the type and quantity of exposure. So it turns out that ultraviolet light comes in many different waves, and it reaches humans anywhere in the environment. So if you're a pilot flying an airplane or a flight attendant, there is UV light radiation high in that atmosphere, as well as for those of us on the ground that receive those wavelengths from the sun and that reach ultimately the earth. So some of this radiation is in the form of visible light that we see. So if you look at the picture on the right, you see that this electromagnetic spectrum of these waves starts off with really high energy. So these waves that contain a lot of high energy, those are gamma rays and X-rays. So if you're a firefighter, EMT, paramedic, think about exposures of radiation that may come when you enter a hospital or a medical facility that has X-rays or gamma rays. Then we'll have ultraviolet light, which we'll talk a little bit more detail in a couple of seconds. Then there's the band of visible light, which is the whole color spectrum. So depending on the wave value, you might have some different colors of visible light, followed by infrared. Then we have some lower energy waves, such as microwaves. So the microwaves we use to heat up our food, and radio waves, which we use to listen to shows and music. So it's of note that ultraviolet light, though, is an invisible. We actually don't see ultraviolet rays, and there's different types of those rays. Their energy tends to be a little bit stronger than what we see in visible light, but they are weaker than the ultraviolet, than the rays that we would see from, say, an X-ray machine. So we talked about those ultraviolet waves. So let me tell you that there's actually different types of them. So we normally label them UVA, UVB, and UVC. So if we look again at this electromagnetic spectrum and we look at the ultraviolet section component, you can see that UVA, UVB, and UVC operate at different wavelengths, where UVA operates around 300 to 400 nanometers in wavelength. UVB, which we consider the burning rays that can hurt our skin, is between 280 and 13. And then UVC, which is between 100 and 280. So if you look at the picture on the right and we look at the ultraviolet rays, you can see that UVC, ultraviolet C type, which is between 100 to 280, has a hard time reaching the surface. And that's thanks to the ozone layer that creates a barrier and limits some of those UVC rays from reaching us, at least those of us that are on the ground. But we do get regular and frequent exposure of UVA, UVB, and UVA rays or wavelengths that do reach humans on the surface of the earth. So as I mentioned, ultraviolet radiation is carcinogenic. It's known to be about a 90% contributor to all the different types of skin cancers that we see in humans. UV can be natural, so meaning it comes directly from the sun and hits us, but we also have man-made ultraviolet, which is tanning beds. So if you've ever been to a tanning bed, it's an artificial creation of UV light. And I'll say UV is also not just, should be thought of in a negative way where it contributes to cancer, but also can be viewed in positive ways as we use them to kill surfaces with bacteria and sort of clean up surfaces that may be infected. So why is UVA and UVB important for our firefighters? So the way I think about it is UVA refers to wavelengths that impact aging. UVA can penetrate deeper layers of the skin, and so can impact long-term aging and give wrinkling faster. And then UVB is the type of wavelength that contributes, I always remember the B for burning. So it's the one that sort of gives us erythema and like burns the skin surface. So solar UV radiation is about 95% UVA is what we see, and then about 5% of what we experience is UVB. UVA, as I mentioned, can contribute to aging, and it causes tanning and potentially skin cancer. And UVB causes more burning and skin cancer. So if you think about tanning beds, they emit 12 times more UVA wavelength than does the sun. So a sun tanning session can contribute significantly to aging and potentially to skin cancer. So of note in this picture that I want you to take a look at on the left is that when we look at the skin, even though you look at your skin surface, it's actually divided into layers. So the top part of this, the immediate top part of the skin right after the hair is the epidermis. The mid part of the skin is what we consider the dermis, which there's a whole array of different types of cells, which we'll talk about in a few minutes, including like melanin that is protective of some of these rays. And the third and final layer is the subcutaneous layer of the skin. So let's dive in a little bit for a few minutes into the skin anatomy and physiology so that we have an appreciation of like why this impacts skin cancer. So this illustration is a little bit more detailed than the previous one and showing us those layers of the skin. So if we look at, I'm going to activate my annotation wizard here, but if you look at a cross section of the skin, so here's like sort of a cube shaped cutoff of the skin. The top layer again is the epidermis. The whole middle sandwich layer is the dermis, and then there is subacute tissue. And so you see that interspersed in the skin, there are hair follicles that come out, and those hair follicles are attached to muscles called pili muscles. So if you ever get goosebumps, it's that these muscles contract and they make the hair stand up, and that's why we get goosebumps. Along the way, in the dermal layer, there are different types of cells that we should be aware about, and blood vessels. So on top of it, there are squamous cells. In the epidermis, there are melanocytes. And these melanocytes contain pigments, melanin, that protect these cells, the keratinocytes, these cells that are in the dermal layer, from that UVB light that comes in and protects it. So actually, when you see somebody with a sunburn and that they've darkened, that's the body's reaction to protecting those cells from that UVA and UVB radiation. So actually, a tan is the body's response to protecting itself. So important to note is that over the years, actually back in 1975, an American dermatologist, Thomas Fitzpatrick, created a classification scheme of skin tones to better understand and characterize some of these experiences of UV light exposure. And so you can theoretically characterize every human skin type into one of these 6 different classification schemes. So you can see the range starts up here at the top with a type 1, which is somebody who has very pale to white skin. These types of individuals, their skin is very sensitive and always burns and really never tans. It gets dark around it. And so those are the types of people that we worry the most about some of the skin cancer development. And then as you go down the Fitzpatrick skin type scale, you go all the way to a type 6. These are individuals that are deeply pigmented and have very dark brown to black skin. So the skin never really burns. It can burn. So I don't want to say that you're not susceptible to burning and cancer, but there's less risk attributed depending on the type of categorization that you fall into the Fitzpatrick score. So how does the skin cancer begin, right? Now that we have an understanding how those cells are layered within the skin. So it begins when these UV wavelengths impact the DNA that's inside those cells. So here in this illustration, we see the double-stranded helix that we remember from biology class in high school, where we have DNA and it has these connections at the different amino acids. So these ultraviolet light rays that come from the sun or from a tanning bed can directly reach the DNA inside the cell and break some of those connections. And so normally as humans, we have the ability to reconnect them in the normal configuration. But if you get a lot of repeated exposure to these types of ultraviolet light rays like A and B, they can persist and that bondage never repairs. And that's where skin cancer can begin. So the cell may grow out of control because now the DNA is broken and the immune system, despite its attempt to try to repair, doesn't, and those cells become, they develop dyscrasia and multiply and can become cancerous. So there are different types of skin cancer that we think about. In the broadest terms, we categorize them into primarily 2 types. We think about non-melanoma skin cancers, which include our basal cell and squamous cell. So now you know they're named basically by their location, where they're at in the skin surface. And then we have the malignant melanoma cells, which again are those melanoma cells that contain the melanin that are on there. And so these are some illustrations of the different types of cancers. You can see that the photos up at the top represent basal cell types of skin cancers. The ones in the middle are of squamous cell origin. And the ones down here on the bottom are the more aggressive or sort of scarier form of malignant melanoma of the skin. So what should we think about here? So studies have shown that there people that have severe sunburns, at least 5 severe sunburns in early life, maybe at double the risk of developing melanoma in later life, right? So like we talked about, if you damage enough your DNA in those cells, it's difficult to repair them, and therefore increases your risk over time as you get older in developing some of these aggressive forms of skin cancer like melanoma. So the best thing that you can do is try to avoid getting burned. A reminder that a suntan is actually our skin's way of protecting us from it. The melanocytes increase the melanin that's in the cells and tries to wrap around the cells that are in the epidermis to protect them from those UV rays. So that's why we tan, but the tan is basically a signal that our body was trying to protect us from those UVA, UVB lights, waves. Keep in mind that even if you are suntanned and you go back out into the sun, that you still get very little protection from that suntan, right? Even the skin, as it's growing again, going back to the surface and sloughing off all those dead cells, that suntan that you have still doesn't give you much protection. It gives a sun protective factor of 3, which, as you know, is very low, and we'll talk about that in a little bit. So skin can get damaged while getting a tan, including from UVA rays and then cumulative lifetime exposure. So there's something else that I want to mention that's important to our firefighters, is that here's an illustration of a skin cell surface. The blue represents the outside environment, and these brown cells are keratinocytes, or the epidermal layer of the skin. So we've talked so far about this yellow thunderbolt here, the radiation that we receive, but we also have to talk about the pollutants that also can potentially contribute to carcinogen. Humans have a special receptor on these cells called the Aryl Hydrocarbon Receptor. So for our veteran firefighters, you recall that we study carcinogenic exposures using wristbands and characterize the polycyclic aromatic hydrocarbons, those products of combustions that firefighters encounter during fire incident response. So these polycyclic aromatic hydrocarbons have the potential to bind to this Aryl Hydrocarbon Receptor, or AHR for short, also activating some of the DNA damage in the cell surface. So as scientists, we're trying to understand the relationship between UV light exposure and the carcinogens that you're exposed to during fire incident response. So there are different ways and different mechanisms of which both UVA, UVB light, and these pollutants like polycyclic aromatic hydrocarbons can trigger cancer to begin with. Okay, so why do we care about this within the fire service? So let me give you some background information on skin cancer burden here in Florida among our Florida firefighters. So you may recall that we presented to you in the past that our senior scientist, Dr. David Lee, leads our Florida Firefighter Cancer Registry and is able to document the incidence, sort of the number of new cases of cancer that happens in the Florida population compared to our Florida firefighters. And so in a paper that he published back in 2006, his team was able to document risk of developing cancer by anatomic site. And so remember this table that we normally show, where we look at all different types of cancers in our male Florida firefighters, and they're at low risk, 0.84. When we look at our female firefighters, we had 52 cases of cancer during this observation period, and they were at a 1.6 increased risk of cancer. But we really only highlighted 3 particular cancers for men, that is bladder, thyroid, and testes. And within our women, we highlighted 3 particular cancers, and that was thyroid, Hodgkin's lymphoma, and cervical cancer that were significantly elevated. In this analysis, Dr. Lee and the team actually identified that male firefighters are at almost 1.2 times elevated risk of skin cancer, although it was not significant, because we probably had very few cases of male firefighters with cancer, 99. And similarly, we saw a 3-fold increase in the risk of skin cancer among our female firefighters, but there were only 5 cases. So fast forward to the year 2021, Dr. Lee updates this analysis, including more years of cancer incidence data, which he just published in 2020 with our colleagues, Dr. Corus and Gall and Dr. Hernandez and others on the team. And in this analysis, he actually found, In this analysis, he found here, you can see melanoma 301 cases, and it is significant on male firefighters at 1.6 times more likely to have melanoma, this aggressive form of skin cancer. And then for our women firefighters, there was 14 cases now, up from 5, and there was a 1.7 increase, although it was not significant, again, likely due to the limited number of cases. And so for us, as occupational health and safety professionals, we worry about this increased risk for melanoma and want to understand a little bit more about how it's starting and in the fire service. Work that was led by my colleague, Dr. Schaefer-Solly, using the annual cancer survey. This is the survey of a cohort of Florida firefighters that we follow over time, documented that Florida firefighters have an elevated prevalence of this aggressive form of skin cancer, melanoma. It's at a rate of about 0.7% compared to the general Florida population of 0.011%. So our Florida firefighters have a higher proportion of them that experience melanoma. And interestingly as well is that the age of diagnosis occurs earlier in firefighters, which is probably, we speculate, a combination of UV light exposure with occupational exposure to these polycyclic aromatic hydrocarbons. In this same analysis, we were also able to look at sun protective practices to try to understand what do firefighters do to protect themselves. So there's a temporal issue here that we don't know what came first, whether the diagnosis of melanoma or these sun protective practices. But what we do see across the board is that firefighters that were diagnosed with melanoma tend to have higher sun protective behaviors or practices compared to their colleagues. And you can see that those with melanoma, represented by the first bar in each group, have more use of sunscreen, wearing hats, long sleeve shirts, and pants. And so all this data taken together raises a scientific gap for us, which is what type of ultraviolet light radiation are firefighters exposed to inside and outside of the work environment, so that we could characterize this contribution of environmental exposure to cancer risk. So now I present to you the FUSE pilot study. So the FUSE pilot study is a short for a pilot study that was undertaken last year called the Firefighter Ultraviolet Safety Evaluation Study. And the primary goal was to characterize UV light both in and outside of the workplace in a sample of career firefighters. We wanted to know, is it feasible to measure ultraviolet light both inside and outside of work, and what does that look like? So the study design is a 2-week repeated measures observational study design. So in English, what that means is we followed firefighters for 2 weeks continuously while they're on and off work. And the target goal was to recruit and enroll 40 firefighters that provided complete data on the study. So you can look at this table here. T1 represents day 1, T2 means day 2, T3 means day 3, and so on, all the way till they get to T14, which is the 2 weeks of observation. So theoretically, any firefighter that participated in the study would have approximately 3 to 4 days of data for which we collected UV exposure while they're on work, and then the other days when they were off work. So if you look here to the left, what does the firefighter do when they begin and when they enroll into the study? At the beginning, we explain to the firefighter the full study. We consent them and get their permission to participate in the research. They complete a baseline survey, so we have an understanding of who they are as a firefighter, their work characteristics, and their tenure as a firefighter. We install an app on their mobile device, which allows for the transfer of information from the ultraviolet light sensor to their phone and back to us at the research laboratory. We trained the firefighter on how to use the sensor. We'll show you the sensor in just a moment. It's called SHADE, which measures ultraviolet light. And we showed them how to maintain it and upload the data back to us. And we also trained the firefighter on how to complete the daily surveys to characterize their daily exposures. And then the final assessment is that the firefighter completes a final survey and returns back to the research team the UV sensor after 2 weeks. Every day across the 14 days, the firefighter is asked to complete a follow-up instrument so that we document what their activities were in that day. So this is what the sensor that we used looks like. It's called SHADE. So it's just a plastic silicone-based wristband. and then a special ultraviolet light sensor at the center that records ultraviolet light rays that hit the sensor. So the sensor reports exposure in units of UV dose. So that is joules over meter squared. So the unit of measurement is joules, which is energy of these wavelengths, over meter squared over a surface of erythemally weighted UV exposure, which is sort of skin surface. So how much skin surface is exposed over time through that space. So we end up using a calculation of exposure of time to induced erythema to explain health risk, right? Because we want to understand, how does this UV exposure translate into health risk? And so erythema means skin burning or becoming red and burning. And so we use an equation that was not designed by us, smarter people beyond us, to calculate how much time it takes to induce skin damage based on ultraviolet light exposure. And so TE is the amount of time it takes in minutes. And there is a factor that's added to that of 4,000 over 60, which allows you to convert from the ultraviolet light that's absorbed by the sensor to an ultraviolet light index in a series of seconds to minutes. So keep in mind that UVI is the UV index. So if you wake up in the morning and you watch the Weather Channel or the weather person tell you the weather, part of what they'll share with you is what is the ultraviolet light index for the day, to tell you how much sun UV light rays potentially reach us on the Earth's surface. The equation also takes into account the MEDF, which is a factor of the different skin types. So earlier I told you about the Fitzpatrick type of scale, and based on our skin type, this equation takes that risk into account. So ultimately, we represent the values and what are called SEDs. So we think about one SED equaling at about 100 joules per meter squared of erythema, which is the amount of time it would take to induce some skin burning based on the type of skin classification that you have. So in the study, I mentioned we used REDCap, which is a wonderful tool to follow and track and administer surveys with participants. We had 4 different types of instruments created here. One was our consent form. One was the actual baseline survey that's done one time at the initial enrollment to get those characteristics on the firefighter. One survey that's called the follow-up that the firefighter completes daily to record their activities inside and outside of the work environment. And the last one is an exit survey to get their feedback on their experience and the 14 days of data collection. Okay, so what did we find? I'm sure you're eager to learn what it is. So data collection for this study occurred between April and June of 2021. This is important because ultraviolet light radiation on a human will vary annually. So it varies depending on where you are in the world, how close you are to the equator, and elevation, if you're highly elevated or not. So in Miami, we have very low elevation. And ultraviolet light rays will vary depending on the time of year. So it's important to note that this time period for which data was collected was April to June of 2021. While our target goal was to enroll 40 career firefighters, only 32 of the 40 completed the entire study protocol, including the surveys and complete ultraviolet light information for each of the day period. So here's who participated. Overall, 97% of the sample was male and 3% were female. In terms of race, 83% self-identified as white or Caucasian. About 59% identified as a Hispanic ethnicity, which is no surprise in South Florida. Approximately 75% of our sample was married. Approximately 52% of our sample identified as some other form of educational attainment, with just a little about 10% of the sample having a master's degree. And this is an important distribution. We'll talk about that when we look at the UV exposure to it. We had a very healthy distribution across years as a firefighter. So you can see about 25% of the sample has been working as a firefighter between 1 to 5 years, and the remaining distribution across. We had different ranks within the fire service. So we had some chiefs and assistant chiefs, some captains, lieutenants, and the largest proportion were our regular firefighter, paramedic, and EMT. We asked the firefighters if they have a second job, which helps us understand, like, when they're not working as a firefighter, what ultraviolet light exposure they might have. And you can see about 47% of those participating said they did have some type of second job. Unfortunately, 72% reported that they do not use any type of sunscreen when they're outdoors, and about 9% of the firefighters indicated they use a tanning bed, have ever used a tanning bed in their life. All right, so here are the results that we found. I want to remind you that data is collected here across a total of 14 days. Some days is within work and some days is without work. So we'll present to you the data summarized and averaged by when the firefighter was at work and outside of work. I will only be presenting to you information of what was significantly different statistically, meaning that we saw actual statistical difference in the UV exposure by these particular categories. But as you saw, we collected a lot of different covariates. So I'll begin by showing you some of the characteristics, how ultraviolet light varied by age, ethnicity, educational attainment, and the years that are working as a firefighter. So here you see 2 bar graphs next to each other. The 4 bars on the left represent the time period when, on average, firefighters were working. The 4 bar graphs on the right represent when the firefighters were off shift or not working as a firefighter. And the 4 bars represent the age group and when they're in. So the light green represents firefighters that are 20 to 30 years old, the orange, 31 to 40, and so on. So overall, what you notice is that firefighters, while tend to receive higher UV sunlight exposure while they're on shift than off shifts. And while they're on shift, there was significant variation by the age, where the younger age groups had higher on average UV sunlight exposure compared to their more mature firefighter that are 51 and older. When they're off shift, most of the firefighters had lower levels of ultraviolet sunlight exposure and were very similar to each other, although statistically significant. We also noticed statistically significant results by the ethnicity. So on average, we see that firefighters that identified as Hispanic tended to, the sensor picked up more ultraviolet sunlight exposure compared to those that were non-Hispanic. Higher educational attainment, as I mentioned before, was very interesting because we do see differences on here. You'll note the light green represents those firefighters that indicated they have a master's degree or higher. The orange represents those that are college graduates, and other tend to be firefighters that completed an Associate of Arts degree or completed their firefighting certification and EMT paramedic certification. And you can see that those with sort of lower educational attainment had higher UV exposure while they were on shift compared to those when they were off shift. And there was a response relationship where we see the higher the educational attainment, the lower UV exposure that the individual has. The last significant difference here was by firefighter work tenure. So how long have you been working as a firefighter? So across the board, we see that while on shift, firefighters that tend to work between 6 to 10 years in their career, have been in the job 6 to 10 years, had sort of the highest UV sunlight exposure, then followed by those that were 1 to 5 years. And those mature firefighters that have already been working 21 plus years, you can see represented by the crimson red and this purple blue, had the lowest UV exposure. And that is true on shift and lower levels while they were off shift. Now let's look at ultraviolet light sunlight exposure by different firefighter characteristics. So we want to report by hours per day when working outdoors, when doing fire attack, when doing a specific work task, and then hours per day outdoors when they're in their leisure time. So we saw these 3 covariates significant. So what you see here is that we're looking at ultraviolet sunlight exposure by hours per day outdoors when they're at work. So this is that they spend greater than 8 hours at work. You can see the UV sunlight exposure is much higher when they're outdoors at work compared to off shift and they're not working. And there's significant difference between the 2. We also saw differences in firefighters that participate in fire attack when doing fire suppression. So firefighters that participate in fire attack tended to have higher sunlight UV exposure compared to those that did not. And obviously those that were not working on shift. So this may be a function of the number of fires and fire exposures that they are during the 14-day observation period. And the last significant result was looking at ultraviolet sunlight exposure by hours per day of outdoors during leisure time. So when the firefighter is on leisure, not in EMS response or fire response, we see the differences in the UV light, where it's actually less UV light exposure when they're off shift. That's there, which is interesting, which means that in the leisure time, firefighters are probably spending more time inside the station, being exposed less to some of that UV sunlight. So I put this table in, which is a little busy, but this is to show you that we looked at many different work-related variables. The 3 rows that are highlighted in yellow were the ones that statistically showed differences in UV light exposure. But we did look at, for example, if firefighters participated in interior attack, where a driver, engineers did forcible entry, to see if there's differences in the engagement of those activities and the ultraviolet light exposure. And statistically significant, we only saw that for the hours per day outdoors, for work and for leisure, as well as if they participate in fire attack. So in summary, what we learned from the FUSE study is that in general, firefighters tend to spend about close to 7 hours per day outdoors for work, and about almost 6 hours, 5.7 per day outdoors. This brief pilot study showed us that the firefighters are exposed to more UV sunlight exposure when they're off shift than versus when they're on shift, although the association wasn't strongly significant. And this could be a function of us having a smaller sample size of only 32 firefighters and some other factors that limits the study group. However, there's some significant points to make a difference here. So we noted that Hispanic firefighters received slightly higher UV dose exposure when they were on shift compared to those firefighters that were not. We also noticed that educational attainment plays a role in UV exposure, where we noted that firefighters with a master's degree or higher had significantly higher UV doses when they're on shift. And this may be that those participants were off shift when the data was collected, or that they tend to have more indoor jobs, such as being an instructor, that could vary their exposure. And lastly, firefighters who were 21 to 5 years of age of working experience, tended to have significantly higher UV dosage when compared to those that were on shift versus off shift. In addition, after we adjust for these different shift factors, we noticed that firefighters who spend more than or equal to 8 hours per day outdoors for work received higher UV dosage of sunlight compared to those that didn't. Participants whose task included fire attack received significantly higher UV dosages, and then participants who spent less than 8 hours per day outdoors for leisure received significantly lower UV dosage. So here's some tips to think about now that we have a little bit of an inkling or insight into sort of the UV sunlight exposure that firefighters receive. Remember that skin types vary. We saw the Fitzpatrick scale of that variation, and you see them here. You look at the column that says skin color, that describes the characteristics of that skin type, and the characteristics of the type of burning that they experience, where a type 1 skin type always burns or never tans. And these are individuals that are fair skinned. So the subsequent columns tell us a little bit about the ultraviolet light index. And this is reported daily by atmospheric scientists and weather meteorologists, and they'll tell you what the UV light index is. So for example, if we look at the first column, when the UV light index outside is between 3 and 5, people with a type 1 skin can burn within 10 to 15 minutes. If the UV index is really high, meaning high penetration of UVA, UVB light on the surface of the earth here in Miami, it only takes 1 to 2 minutes for that skin to burn. And so you can use this table as a way to sort of think and stratify risks based on UV index that's out there. There's a couple of things our firefighters should think about. There are UV monitors. You saw the ones we used in this study, shade, to characterize what the firefighters were experiencing, but there are ambient monitor UVs that could be done to be aware of what ultraviolet exposure looks like. It's important to use cover-up clothing that's breathable, but allows protection from UVA, UVB rays. So using clothes, sunglasses, and hat when possible. And then the idea of using sunscreen with high SPF factor. It's important to choose sunscreen that's at least 30% or more particularly when you're outdoors around really sensitive areas on the face and on the tips of the ears and on the lips, to protect it. Make sure you're using a broad spectrum sunscreen that it protects around UVA and UVB. Try to get into the habit of using daily, especially if you're on shift. Make sure you apply some sunscreen at the start of shift at 7 a.m. And importantly, don't forget lip balm to apply at least with SPF of 15, because our dermatologist colleagues report, that people have skin cancer that appears on the lips, and you can protect them by using a lip balm of at least 15%. So just a quick note on SPF, because it can be very confusing. You go to a store to buy some sunscreen, and it has different numbers of SPF. So SPF stands for sun protective factor, and this is the ability of that sunscreen to reduce the UV rays that ultimately reach you on the skin surface and are reflected back. So the SPF is really like a marker of like how long a sunscreen will protect you from the skin and from sunburn. So SPF is really a measure of UVB protection, right, for the skin surface, not really a measure of UVA. Again, remember, UVA is for aging, and it's the UV light that penetrates in the deeper layers. So the way to think about it is the strength of protection is that if you're using a sunscreen that says that it's an SPF of 15, it blocks about 93% of UVB rays. And as you increase that sun protective factor, say SPF of 100, it's basically screening out 99% of the UVB light. But it's important to note that no sunscreen that exists blocks 100% of UV light completely. Some tips to think about from my dermatology colleagues to remember is that if you do see molds on your skin, keep tabs of it. Do a self-check. Make sure that you talk about it with your primary care physician or your dermatologist. But here's something that you can do practical at home. Please know that skin cancer is preventable. At least 95% of skin cancers are, and you should be looking for spots or mold that are on your skin. Things that should catch your attention are sores that actually don't heal, like you saw in the basal cell pictures, basal skin cancer pictures. If there's sores that don't heal, that's something that's important to monitor and keep track and get checked out and talk about with your doctor. So here's something to remember when trying to evaluate skin lesions or skin moles. First of all, you're not a dermatologist, so make sure your doctor sees it. But things to keep in mind, the ABCDs for moles. So the first thing is look at a skin mole and look for the symmetry of it. Is it a perfect circle, or does it have, they don't really match each other? So if a lesion looks asymmetrical, like you see here on the right, let me just do it over here. So if you do the asymmetry here on the right, sorry, I was trying to point. You will notice that it's not a perfect circle, right? And there's some asymmetry here with the lesion, so that's sort of concerning. The next thing is look at the borders. Are the borders ragged or irregular or poorly defined? This would indicate something that is maybe of more concern than a regular mold. Also look at the color. So usually benign things are all one uniform color, but if you see that color varies from one section to another, with the sort of different shades of brown or black or white, that could be of concern. And then also the diameter. So we worry about lesions that are about 6 millimeters or greater in size. So 6 millimeters is about the size of a pencil head. If it's larger than that, then that's something that definitely needs attention. And then the letter E is for evolving. So is that changing over time? Is that mole growing and looking a little bit different than it does? So that's the end of my presentation. I hope you learned a little bit about ultraviolet light exposure. We're really excited about the pilot study and these preliminary findings as they begin to give us some insight into the ultraviolet light that career firefighters are exposed to both on work and outside of work. And I'd be happy to entertain any questions from the audience.
Thank you, Dr. Caban. Awesome presentation. Really great information for our firefighters. So I open it up. If anyone has any questions, feel free to put it in the chat. I know some people already asked about if this is going to be posted. So this will be posted to our YouTube channel along with all of our other seminars. So please feel free to view them there or share them with others. Okay, so I don't see anything coming through, but I have a question, Dr. Bond. So, you showed the data and how we see that firefighters are in the sun more when they're off shift. You've also shared some great information and tips for firefighters of how to prevent skin cancer. What do you think fire departments should do at an organizational level to promote skin protection?
Good question. So I think, there's opportunities for the individual firefighter to work on sun protective practices. And then there's things that as a fire department, we could work on. So the first thing is screening. So a fire department should consider organizing once a year skin cancer screenings. Reach out to your local dermatologist and see if they'd be willing to go to the fire stations and do a general head to toe checkup of the skin of the firefighters. And head to toe literally means check every surface of the skin for that. And I think organizationally, having the fire department organize that event as a skin cancer screening awareness and check is really beneficial. Not only for making the relationship with a local healthcare provider for skin cancer, but also to have an understanding of any potential risk areas that are there. Another thing that a fire department could do is technically provide sunscreen lotion, right? So just like we have dispensers for hand sanitizing, should we have dispensers to support some sort of SPF level protection, where when you start shift, you could apply some, on your skin surfaces and protect there. So I think the responsibility should be shared, not just the individual firefighter, but if the fire department can provide certain sun safety measures while the firefighters are outdoors doing some of that, their work.
Great. So we do have a couple questions that came through. Do you think this was a representative sample or a pretty select sample?
Yeah, I think this is what we call epidemiologically like a convenient sample. We circulated a study flyer. Catalina and Allison engaged different firefighters at different fire departments. So this represents different South Florida fire departments, but it was basically people that had expressed interest and said yes, that they wanted to be into it. So this is in no way a representative sample of all firefighters. Although you saw we had different mixes in both race and ethnicity participate. So I would say that, these results may not necessarily represent, definitely do not represent the entire Florida firefighter workforce. I think this has given us motivation and curiosity about wanting to do this at a larger scale, to be able to quantify these exposures, not only because it was done in a short time frame of 2 weeks, but also because ultraviolet light really fluctuates throughout the entire year. We would need to get normative data of exposure over a year to better characterize ultraviolet light exposure. But this is a first step. I think I can confidently say this is the first study to look at ultraviolet light exposure in firefighters, which is really important because last month when we came back from the International Agency of Research on Cancer, skin cancer was elevated to a status of limited evidence of risk for firefighters. And part of that limitation was not knowing enough about ultraviolet light radiation. So now we have a study that can contribute to some of that knowledge base. But we need to, in my opinion, increase the number of firefighters that participate in this important work.
Absolutely. So what is the recommendation for reapplication of sunscreen while on shift?
Apply frequently. So oftentimes our own sweat and other exposures, with shirt touching will diminish, but I would say anywhere between, 2 to 4 hours, reapply, depending on the activities that you're doing. When in doubt, just reapply. It doesn't hurt to reapply sunscreen on there and sort of limit the SPF rays while you're there.
Yeah, and I'd also like to add, if you haven't listened to our 30 and 30 Out podcast, we actually did one on skin cancer with a firefighter cancer survivor, but also Dr. Natalia Jaimes, who's a dermatologist here at Sylvester Comprehensive Cancer Center, who's seen several firefighters. And she talks specifically about this. And I know in the podcast, she was saying every 2 hours, especially if you're sweating a lot. So that definitely would relate to our firefighters. We have a couple more questions. Does firefighting exposure increase skin cancer?
So the epidemiologic data suggests that firefighters have an increased risk of skin cancer compared to the general population. Now, the question about how that happens through UV light exposure and potentially synergistic effects with exposures to pollutants, such as polycyclic aromatic hydrocarbons, is something we're unraveling, like with our colleagues, Dr. Sylvia Donner, Dr. Dow, and our biochemistry team, and understanding how those exposures reach the firefighters and are combined. But in our Florida firefighter epidemiologic data, we do see an increased risk for skin cancer within the workforce.
And then I do see, did you, Dr. Lee, or anyone look into the actual skin color, not just ethnicity and correlation, or any correlation with skin cancer in the firefighters? For example, difference in firefighters with very fair skin with light eyes versus Mediterranean versus darker skin and dark eyes.
Yeah, for this pilot study in Fuse, we haven't looked at the skin type, that Fitzpatrick scale, where you can characterize them, whether they're like a group 1 or 6 on the skin type. We haven't done it. This pilot study was really a feasibility study. You know, can we put sensors on firefighters, have them wear it on work and not work, and characterize those UV? Really, a dermatologist needs to sort of characterize a person's skin type. And so we are motivated to repeat this study with a larger sample of firefighters and actually characterize the skin type so we can see that relationship. And keep in mind that you know, skin cancer does take some time to develop. So we would have to follow these firefighters over time to see how their skin type and then their characterized UV exposure ultimately leads to skin cancer development. You raise a really good question, which is, could we use maybe some epigenetics and look at DNA methylation and see if there's early biological changes in skin cancer based on the UV exposure? And I think that's a great idea, and we could definitely look into that.
Great. Does different areas and climate make a difference?
Oh yeah, absolutely. So I'm not an atmospheric scientist, but I'll tell you for sure that based on where you're geographically located, the risk of UVA and UVB light will change. So if you're closer to the equator of the Earth, which we are here in Florida, the risk of UVA, UVB light exposure is higher because we're, you know, sun's rays hit more closer. And then at the poles, if you're the Antarctic or not, the UV rays don't hit as much or penetrate there. Also, if you're at higher elevation, so let's say you're in Denver, Colorado, you're at a higher elevation than say here in Florida at sea level, you're at a higher risk because you're closer to those UVA, UVB rays to hitting your skin directly. Also, cloud coverage, right? And ozone layer. So the ozone layer of the Earth is not uniform throughout. There's areas where it may be scant and the UVA, UVB can go through, or there's areas that there's more rich in ozone. And so that climate and that atmosphere will change the amount and type of UV sunlight rays that will ultimately hit the firefighter on their the skin surface.
Perfect. And our last question to close out is, did any of the firefighters that participated and had higher exposure, did any of them report any skin lesions that may be suspect of melanoma? Okay,
great question. So yeah, 4 of our 32 firefighters, I didn't include this in our slides, but 4 of the 32 did report a doctor diagnosis of skin cancer. Not all of them were melanoma. I think we had 1 melanoma and 3 were non-melanoma types of basal and squamous cell. So yes, 4 out of the 32 did have a doctor diagnosed skin cancer.
Great. Well, thank you. I mean, this was super informative. I think we got a lot of information, a lot of questions answered, and we look forward to the next steps of this project. So everyone, thank you so much for joining another seminar series with us. We will be sending out the invite for next month's seminar series, and just please check your emails for any other announcements that FCI sends out. Thank you all for being here.
Thank you. Bye.